So welcome back. We're going to keep going with more free response questions today, talking about accumulation and rates of change.
Okay.
So I'm going to focus more on explanations today of what's going on with our average value and our average slope. So our average value is kind of the same thing that we normally do when we get an average between a data set of numbers, only we'll be doing it with a function instead. So if I had a set of numbers like 5, 7, 9, 11, 13, 15. If I wanted to get my average of these numbers, what would I have to do?
Just the average?
Yep.
We just add them all together and divide it by 1, 2, 3, 4, 5, 6.
Perfect. So I would sum all the numbers in the data set and then divide by the number of numbers. Okay, that's kind of the same idea that we're going to be doing when we want to get the average value of a function. So I'm going to sum all the numbers together, which means if I'm adding up all the y values, that's exactly what we do when we integrate, actually. So when I integrate, I'm adding all of the y values together for a function from x equals a to x equals b. So I'm going to integrate, which is adding all of my values together. And then I want to divide by the number of numbers, just like we do when we normally get an average. So I'm going to divide by however many values were between a and b, which will be my difference between a and b. So I'm going to start with my larger numbers, that's b, and then subtract a. Okay, so the math is exactly the same as what we did for the number set, just for a function. As far as units go, when you integrate, you multiply your units together. So let's say f of x is velocity and x is time. Then this would be velocity times time would give me a distance or a displacement after you integrate. But then you divide by a change in x. So if you have a y over x, that'll bring you back down to velocity if I have distance divided by time. So our units in the end don't actually change. The same way that our units don't actually change when we get an average value of numbers in a data set. Okay, so I'm going to give us one example.
Okay.
Let's say I have y equals the cosine of 2x. I'm going to multiply by some number on the outside, so we'll go 2/3. I have y equals 2/3 cosine of 2x. I'm going to go from x equals pi to x equals 3 pi over 2. I want to find my average value on this interval. So if I graph this, the graph will look like this.
But
Okay.
what is the average value then? Is it a point or an area? Point or?
So my average value, kind of like what you did with the data set, is just going to give us one number. This is the average y value that you have on your interval. To get it, we'll first get
okay.
our area, so it's
Average.
adding all your y values together, but then you divide by your change in x. So this is sort of like summing up all of your numbers together, like you did when you had the 6 numbers that you added together. But then you divided by the
Okay.
number of numbers, which is dividing by your change in x. However many numbers that you added together when you did your interval is going to be however many numbers were between your start point and end point. And when we're integrating, we're getting infinitely many numbers that we're adding together, but infinitely many y values. When you divide by that space that you had for all of those y values, though, that's your change in x, you'll get back to a in average value, so your units will not change. Okay, keeping with this example, So I've got the cosine of 2x times 2/3 from pi to 3 pi halves. So if I plug in pi right now, this would be the cosine at 2 pi, which is 1 times 2/3 is 2/3. So at pi, my y value is going to be up here at 2/3. At 3 pi over 2, that's 3 pi over 2 times 2 is 3 pi. The cosine at 3 pi is negative 1 times 2/3. Will give me a value that is somewhere down here at negative 2/3. So my function looks like this. Okay, then I'm going to integrate. When I'm integrating, that will add all of these y values together. So again, just like when we normally take an average, I'm going to add all of my values together first. Then I'll divide by the number of values that we had. So this is I guess I'll go over here somewhere. And if I need to, I'll move over to the other side. So this will be the integral of 2/3 cosine 2x from pi to 3 pi halves. Okay, so if my u is 2x, that means my u prime is 2dx. Okay, I don't have a 2dx, I have just a dx on the outside. I do have this 2 from the 2/3 that I could use for my 2dx. That means I have a 1/3 that I'm not going to use. So I'm going to pull out that 1/3. Here's my 1/3 that I can pull out. Then I have a 2dx that I can substitute for u prime, and a 2x that I can substitute for u. And that will also change my bounds. U at pi is 2 times pi is 2 pi. U at 3 pi over 2 is 2 times 3 pi over 2. Again, I'm using my function here. If u is 2x, then I should be able to multiply these bounds by 2 in order to get my new bounds, is 3 pi. So if I want to rewrite this integral in terms of u, I would get the integral of 1/3, which I've just pulled outside because that's a constant multiple, from my lower bound of 2 pi to my upper bound of 3 pi of the cosine of u times u prime. Okay, when I integrate that, I will get, ran out of room on that line, so I'm going to move over to here maybe. When I integrate that, I get 1/3 times the sine of u, from u is 2 pi to 3 pi. And then when I plug it in, this will be 1/3 times the sine of 3 pi minus 1/3 times the sine of 2 pi. Okay, the sine at 3 pi is 0. The sine at 2 pi is also 0. So this is 1/3 of 0 minus 1/3 of 0 is 0. Which we can kind of see from our graph. This graph is symmetric. So if I add all of these positive values here from if I add all of these positive values from our start point to our midpoint, and then I add all of these negative values from our midpoint to our end point, they'll all cancel out. Any questions on what we did?
No.
Okay. Key for average values are units don't change. So whatever units you started with, if you started with velocity, after you do your average value, you are still velocity. If you started with distance, after you do average value, you're still distance. Okay, I'm going to contrast that with my average slope. My average slope, if I started with velocity, would give me my average acceleration. It's an average, which means we're checking against an interval. The way to find it would be my rise over run, or change in y over change in x from algebra. It is not as exact as an instantaneous slope, So I'm not finding the acceleration at a single point. I'm finding the average acceleration over a range of values. So my meaning is different.
Okay.
If you just derive your function, you'll find your acceleration at exactly whatever time you want. So that's at one moment in time. Versus if you find an average slope, you're finding your acceleration on average over a time interval. Either way, when you derive or when you get an estimate for your average slope, you are changing your units now. Your units are now y over x for whatever your original values of y and x were.
Okay.
So slope is a change in y over a change in x. Your derivative is delta y over delta x. Or the change in y over change in x at a single instance. That's the limit as your change in x approaches 0 of that change in y over change in x. Okay, any questions on the difference? Average value, average slope, for anything we've covered so far?
No.
Okay. So I'm going to do one problem, and then I forget who asked, but someone asked me to go through one of the homework questions from yesterday, so I'll go through that afterwards. So I've got this equation for the traffic flow of cars passing through an intersection measured in cars per minute. It's modeled by this function, 82 plus 4 sine t over 2 for 0 to 30, where f of t is measured in cars per minute and t is measured in minutes. The first thing I want to do is, to the nearest whole number, estimate how many cars pass through this intersection over the 30-minute period. What do I need to do?
Point 0 to 30.
Integrate.
Okay, you're right. Integrate from 0 to 30. Of what?
Ft.
F of t dt. Perfect.
Here.
Okay, so this is your rate, so that's cars per minute, times your change in time, which would be minutes. So my final answer then would be cars. Okay, so if I do this, I'm going to integrate from 0 to 30 of 82 plus 4 sine t over 2 dt. And let me check really quick. I believe this is the first question, but I actually didn't write that down. Question 1, yes. Okay, so this is with the calculator. So I am expected to do this in the calculator, so let me go ahead and jump that up. This is f of t, which I'm probably going to use more than once. So I'm going to hit y equals, and we'll type that in for one of our variables. This is 82 plus 4 sine of t over 2. So that's sine x over 2 for us in the calculator. And now whenever I need to use it, after I quit back out, if you hit variables, y variables, function y1, that'll just plug in everything we just typed. Okay, so I want to integrate. So this is math 9 is my integral. Our function, which we just stored as variables, y variables, function y1. I'm going to integrate that function ft in terms of our variable, which for us is x, from our lower bound of 0 to our upper bound of 30, from 0 to 30. Okay, so that gives us 2,474, 0.077. 474.77. Okay, but this does say 0.077, my bad. This does say round to the nearest whole number. So what should my answer be here?
2,474.
Perfect. My units are cars. Again, if f of t is cars per minute, and dt is measured in minutes. Then my units will be cars. Okay, any questions on what we did?
No.
Okay, then for part B, I want to know whether the traffic flow is increasing or decreasing at t equals 7 and give a reason for it. Oliver, what do I have to do?
Find the slope.
I want to find the slope of the number of cars. Which function gives me the slope of the number of cars?
We can find the slope if. Pardon?
Do you mean you want to find f prime t, or do you want f of t?
F prime t.
Okay, so f prime t, my units for, if my units for f of t are cars per minute, then my units for f prime t would be cars per minute
Where cars per minute
squared. Okay, if I want to know whether the traffic flow is increasing or decreasing, my traffic flow is already a rate, so you're right. If the traffic flow is going to increase or decrease, will be the derivative of this. Now, if they had asked, are the number of cars increasing or decreasing at t equals 7, then that would just be f of t. But because they're asking for traffic flow, this one is going to be f prime. And my units for that is going to end up being cars per minute squared, not just cars per minute. Okay, so this is my derivative of this would be f prime at t, which I'm going to write a general form for first. So what happens when I derive f of t?
Uh, 2 cosine t over 2.
2 cosine t over 2, perfect. dt. And I'm going to plug in our number, t equals 7, to get 2 cosine of 7 house. Which we can get. So this is 2 times the cosine of 7 halves is negative 1.873. What are my units?
Meters times cars per minute squared.
Cars per minute squared. Okay, so my traffic flow is decreasing. The traffic flow is decreasing as f prime at 7 is negative. Okay, any questions on B?
No.
Okay, moving to C. I want to know the average value of the traffic flow over the time interval 10 to 15, and then indicate the units of measure. If this is an average value, what will happen to my units?
Stay the same.
Stay the same. Okay, so my units should still be units for traffic flow. My traffic flow is defined as the rate at which cars pass through an intersection, which is ft. So my ft is cars per minute.
Hello?
Hello, can you hear me? Not
Okay,
muted?
yeah.
Okay, there we go. So my units do not change. My units are going to stay the same for traffic flow, which is still cars per minute after we do this. What's my formula for the average value if I want to go from 10 to 15? Average
P minus A
traffic flow equals...
integral of F2.
Okay, you said 1 over b minus a, so that's 1 over 15 minus 10 times the integral from a to b, so you said was 10 to 15 of what?
from 10 to 15.
Okay, from 10 to 15 of what am I integrating?
F of t.
F of
F
t.
to T.
Perfect. F of t dt. Okay. And because this is with the calculator, I believe that's all we have to write actually. So we can just solve this now. So my average traffic flow is 1/5. 1/5 times math 9 times my integral of f of t, that's variables, y variables, function y1, in terms of x from x equals 10 to x equals 15. Okay, which gives us 81.8999. And we said our units do not change, so this is 81.8999 cars per minute. Okay. I think I can leave it like that actually. Since this is a rate, it's okay for this to not be a whole number. Any questions on what we did for average value?
No.
Okay, last one. I want to know what the average rate of change would be for the traffic flow from 10 to 15, and then indicate the units of measure. Average rate of change of the traffic flow.
The average rate.
What is a rate of change? What's another word for rate of change?
Slope.
Slope, perfect. So this is just asking for the average slope of the traffic flow. So that's the average slope of f from 10 to 15. What do I have to do?
Mm. Integrate 10 to 15.
Sorry, you broke up there for a minute. Can you say it one more time?
Integrate 10 to 15.
Won't need to integrate.
FB minus FA over 15 minus 10.
Okay. So this is f15 minus f10, b minus fa, just like you said, over b minus a, which would be 15 minus 10. So this is average rate of change of the traffic flow from 10 is less than t is less than 15. Okay, it's just an average slope, so that's our average formula for y2 minus y1 over x2 minus x1, so my average slope. And then I'll plug this in to get my f of t's. So that gives us okay, our y value at 15, so I'm going to go variables, y variables, function, y1, and just put in parentheses 15. Okay, so that'll give me my, what happens if I plug in 15 into our function. Okay, and I'm going to subtract. What happens if I plug in 10 into our function? And then divide by 5, 15 minus 10. Okay, so that gives me 1.518. And then what are my units? If this was the rate of change of traffic flow.
Cars per minute.
Close.
Mean square.
Cars per minute squared. The reason why is because f of t was already cars per minute. So when I derive, that'll be cars per minute, which will be cars per minute squared. Okay, if I wanted to subscript this, I could say something like this. This is f prime t, but as an average. Average from A to B. Any questions on anything we did for this one?
No.
No.
Okay. I'm going to throw up my scoring guide just so you can see how you're scored. So first one, I was looking for how many cars pass through. They've got 1 point for the limits, that's from 0 to 30, 1 point for the integrand, we integrated f of t, and 1 point for our answer of 2474. So we did all three of those, so we should be good on all three. Limits, integrand, and answer. Okay, I'm not sure why I can't write, but limits, integrand, and answer. 1 point for our answer with reason. Our traffic flow is decreasing when the derivative is negative. Okay, we did that. Average value, 1 point for limits. That's 10 to 15. 1 point for your integrand. We integrated f of t, and 1 point for your answer, 81.899. Okay, we got the same answer. That's good. 1 point for our answer for d of 1.1, 1.517 or 1.518 cars per minute squared. I think we match. Yes. So we're okay there. Then last one are the units for both C and D, cars per minute and cars per minute squared, which we're okay in. Okay, so we get full credit for that. Okay, then I was also asked to go through this one. So this is question 4 from your homework. So I'm going to do that really fast. So we had this function, and we were also told what our start point would be. F of 0 is 3. We were given the graph of the derivative, this is not f, which has one line segment and one circle. So from here to here is a line. I want to know first, over what intervals would f be increasing, and justify your answer. If f is increasing, then f prime should be positive. And if this graph is f prime, then my y value for this graph is positive only between -3 and -2. So I can say f prime x is positive, is greater than 0, on the interval from -3 to -2.
Which number was this? Number 4?
Yes, this is
Or-
question
or
4
number-
from yesterday's homework. We're doing part A. That does actually include -3 now that I look at this. That's a closed dot up there. So I'm going to change this parenthesis to an open parenthesis. But the -2 needs to stay closed because at -2 the slope is 0, not greater than 0. Okay, so this will be f is increasing on the interval from -3 to -2, where -3 is included, -2 is not included, as f prime x is greater than 0. Okay, part B. Find the x-coordinate of every point of inflection for the graph of f. To be a point of inflection, what has to be true?
But isn't the point from 2 to 4 also decreasing?
Can we go back?
Oh, it's increasing, or
We're looking for increasing. This graph is f prime already. So that means we're looking at the y value of what they gave us in the graph. If the y value is positive, then my original f would be increasing. If the y value is negative, then my original f would be decreasing. So my original f is decreasing for all of these values because my y value of f prime is negative. because this graph is not the graph of the original function, this graph is the graph of the slope. So whatever the y value
so
of this
it's
graph is negative, the slope of the original is negative.
so the original is negative. It's never increasing.
The original is only increasing from x equals -3 to x equals -2.
To -2.
Yep.
Okay.
So that's when the y value is positive. But after that, for everything after -2, the original graph will be decreasing since our slope is negative.
Okay.
The confusing part about this is they didn't give us the graph of f, they gave us the graph of f prime. So we're not looking at the original function's y values here. We're looking at the
Okay.
we're looking at this graph of the slope. Okay, so if I want the point of inflection of f, a point of inflection is whenever the second derivative changes. So because this is already the first derivative, the slope of this graph will change around any point of inflection. So I've got 2 points where we change slope. Here my slope of f primes, that's f prime prime, was negative. Here my slope of f primes, that's f prime prime x, was positive. And then here f prime prime x was negative. So I have 2 points of inflection, 1 point of inflection at x equals 0 and 1 point of inflection at x equals 2. So we have f has points of inflection at x equals 0 and x equals 2 as f prime prime x changes sign at these points. Point of inflection is any point where your second derivative is undefined or your second derivative is 0 and the concavity changes sign. So our concavity changed from concave down to concave up at x equals 0 and from concave up to concave down at x equals 2.
Okay.
Any questions on part B?
No.
No.
Okay, part C. Find the equation of a line tangent to f at 0, 3. Our general form for a tangent line is y minus b is equal to y prime times x minus a. So this will be y minus b is my y value for that point, which is 3. My derivative at 0 is -2, since it's the y value of our graph that's showing. So that's -2 times x minus our a value, which is 0. Okay, so if I wanted to write this would be y minus 3 equals -2x. If I needed to write this in slope-intercept form, then this would be y equals -2x plus 3. Any questions on the tangent line?
No.
No.
Okay, and the last one. So I think this is the part that somebody was asking me about, but for part D, find f of -3 and f at -4 and show the work that leads to your answers. So I'm going to split this. We'll do one side -3 and one side for +4. In order to find a y value, as long as we have a start point, which we were given, f of 0 is 3, I can take the start point and then add the integral of the derivative. So that'll tell us how much our y value changed. So that would look like this. F of -3 should be f of 0, my start point, plus the integral of f prime x dx. That's how much our y value changed, would be integrating the slope of our value from our start point, x equals 0, to our end point, x equals -3. Okay, my only problem here is I'm actually integrating backwards, right? From 0 to -3 is from right to left, not left to right. So to do that, I would change our integral's sign. This is f of 0 now, instead of plus minus the integral from -3 to 0 of f prime x dx. Okay, so my start point f of 0 was 3, so that's 3. minus the integral from -3 to 0 of f prime x. So that integral is my area underneath the curve from -3 to 0. I've got two triangles in that interval. This first triangle is a 1 by 1 triangle. The second triangle is a 2 by 2 triangle. So this area is going to be 1/2 of 1 times 1. So this area is positive 1/2. This area is 1/2 of 2 times 2, is -2. So this is 3 minus our areas when I add them together. 1/2 minus 2. 1/2 minus 2 is 1/2 minus 4 over 2 is 1/2 minus... Okay, so that'll give me 3 on the outside, so that was my start point, minus the -3 over 2. So that's 6 over 2 minus -3 over 2 is 6 over 2 plus 3 over 2, or 9 over 2. Should be f at -3. I'm going to do the same idea for f of 4. F of 4 will be our start point at f of 0 that we were given, plus the integral from 0 to 4. So that's from the start point to our end point, of f prime x dx. Okay, this time I don't need to change the integrals because I am going from left to right already. This area, though, is a little bit trickier. Oops, here. So I'm looking for this area plus this area. So what I'm going to do is I'm going to take this whole box here, and I'm going to subtract the semicircle from the box. That semicircle has a radius of 2. So the area of a circle with a radius of 2 would be 4 pi, and this is half of that, so this is 2 pi, is my area here, for the semicircle. And then the area of the entire box is a 4 by 2 box, so it would be 8. So the area of both of these white spaces added together would be 8 minus 2 pi, which is the area we need, only that area would be negative because we are below the curve. Okay, so that is -8 minus 2 pi, or 2 pi minus 8. Okay, so I've got f of 4 is our start point, which was at 3, plus 2 pi minus 8. Okay, the 3 minus 8 is -5, so that's 2 pi minus 5. Should be our y value for f of 4. Any questions on what we did?
No.
Okay. So I've got the 2 other free response questions for today. We did question 1 today, so you guys need to do 2 and 3 for homework. For the...
And what was 4 and...
I'm sorry, I don't understand the question. You're asking what
the
numbers for the
previous-
homework, or you're asking for...
Yeah, this today.
Okay, today's homework is question 2 and 3.
1, 3.
In the packet that I sent through Skype and WeChat. Okay, complete questions 2 and 3. From the 2004 free response questions, included in the file above. Okay, I'm also going to send the PowerPoint with all the annotations. So that's everything that we wrote today, as a separate file. just for notes. As soon as that finishes saving. There we go. Okay, and I believe that's it for the weekend, so that'll be due on Monday at 9 a.m. And if you guys have
Okay.
questions, please let me know. I am at some point through today and tomorrow, I'm trying to email, WeChat everybody to tell them if they're missing any stuff. The quarter technically ends this week, actually ended yesterday. So we're cutting off in the middle of the week. But I can still edit grades until the end of Wednesday at midnight next week. They're actually printing out Thursday morning now. So I've got until Wednesday to
Okay.
fix stuff. Before I break for the weekend, I will send you a message saying if you're missing anything for quarter three. If you are,
Okay.
please get it to me as soon as possible. That way I have time to grade before grades are frozen Wednesday.
Okay.
Okay, thank you.
Okay, thank you. Have a good weekend.
Bye.